Let's talk a bit about part coordinate systems in Adams View. Whenever you create a rigid body in your Adams model, Adams View will create a part coordinate system that is actually located at 0, 0, 0, which is the global origin. So even though you can't see any marker at the global origin, there is one there. And to try and prove this, if you take a look at your part and you do an info on the part, it looks a bit confusing. It says that the location of your part is 0, 0, 0. It clearly is not 0, 0, 0, at least for the CM marker. If 0, 0, 0 should be at the intersection of the white lines down here. If I look at the CM location, I get information on that. You can see that the CM is at 100, 250, 0. Yet, again, when you get information on the part, it says that the location is 0, 0, 0. So Adams Solver needs a part coordinate system for every body in the model. And so what I'm going to do, just to help visualize this, is I'm going to add a marker onto this body at the origin location. So this is where the part coordinate system would be down here. If I take this model and I simulate it, say for 0.2 seconds and 20 steps, and then I go to Adams Post Processor, and let's say I go into result sets, and for this part you're presented with the part 2 transform. When you're looking at result sets, this is the raw Adams Solver information. If I plot the y, it looks as though, as it should, the ball falls down. If I plot the x though, it looks a little bit strange. It says that the x location of this part is at 0. This is because it's plotting the location of the part coordinate system. This is not the CM location of your part. So beware of that when you're looking at this raw data in terms of result sets, not in terms of objects. If I go back to my model and I take this part and I select it, and let's say I move it over slightly. So when I move this part over slightly, you can see that the green marker here, which I put in to visualize the part coordinate system marker, this green marker moved when I translated the ball. So let me just push that back and then repeat the operation. So as I move the rigid part around, all the markers that are attached to it move with it as well. So when you've translated the part through some distance, and if you now do a part information, it now tells you that your part information is 300, 0, 0. That's because you've translated this marker over by 300 units. And so if I resimulate this system and let the ball fall down and go back and now plot this again, I plot the x position, you can see that instead of originally being at 0, I translated the ball over in the design configuration, and now the position in the raw information from Adams Solver of the ball is at x is equal to 300. That's because I translated it by 300 units before I did the simulation. So you have to be careful about the difference between the location of, say, the CM marker, which you can measure. That's probably what you want when you want to measure the position of a part, versus the raw information that Adams keeps track of, which is called this the location of the part.